Welcome to the first video in Control System series. We're going to start this series with a question from the textbook. So this question asks us to find the transfer function of the system shown in the figure below. So as you can see, we have this block diagram, right? We have an input TDS and RS, and we have an output YS. Now, how do we find the transfer function? Well, to do that, there are two methods. One is to use the block diagram transformation as shown here, right? And then the second method that we can try is by Mason's signal flow, which has a formula of its own. So we're going to go through both of them by this example, hoping that it will clear out some of the questions that you might have. Now, the first thing that we have to do is to I will decide to solve this using this block diagram transformation. Now, if you want to solve it this way, let's look at what we want to do. So, a transfer function, the final form that we have to achieve is basically some input, right? Followed by this transfer function. We're going to just call it HS, and then the output. This HS is not this HS, okay? Don't confuse that. This is just a transfer function that I'm suggesting. So that's the final output. Now, how do we transfer this system into this system? Okay. All right. So let's go ahead and solve it. So now that we have a general picture of what we should achieve, now we're gonna go on, and solve it. So the first step is for us to get rid of this this sign here, and it means that we have to move this, right? We have to move this in here because we don't want this here. So we can see that this one has the input TD of S, and if you look at this block diagram transformation, which one does it represent? So we can see that we have this sign here. We want to move it here. Now let's look. So that would be 5, right? Because they have this sign and they moved it behind G as shown here. But what they did in the process is that they had this input X of X2, right? X2. They moved it behind G and it became 1 over G. So X2 times 1 over G, which is this one. So it means we're gonna have to do the same. So, so we're gonna draw this, okay? Plus, minus, and okay, I'm going with plus, plus, minus. So this is RS. This represents HS, and we're just gonna have, because we're saying we removed it, right? So just gonna be G1 of S, G2 S, and YS. So we said that we moved this one here, and by doing that, it means we have to do what? We have to do this TD of S divided by, if you can see here, right, TDS comes after G1 of S, so G1 of S. So that's our input. And then, because look, okay, let's consider this 2. We have TD of S multiplies with G2 of S, right? And this leads to Y of S. Now let's consider this, okay? TD of S over G1 of S multiplied by G1 of S, G2 of S, which leads to YS. Now, are these two equal? Are these two the same? Yes, they are. Because in the initial system, we had TD of S multiplied by GT of S gave us Y of S. And in this system, we have TD of S. If we cancel this with this, is just TD of S times G2 of S equals YS. See? So that's how we know that we got the transformation correct. Okay? So it's a good idea to check always if you did the correct steps. So now that we got that figured out, now we have to get rid of this loop, right? Because as we can see, we have this loop here that we don't want. How do we get rid of this loop? Well, let's look at the transformation table. Eliminating a feedback loop. They have this loop, and that's how they have this final form. If you look at this, right, what they did was they said it's G plus minus 1 GH, which is a multiplication of these two. So this new loop will be G1 of S, G2 of S, see, divided by 1 plus or minus this times that. So G1 of S, G2 of S, H, S. Sorry for my bad handwriting, I'm not a very good at that. So this is our input, this is TD of S, G1 of S. Now we can see that we have a plus minus here, same thing here. Which sign should I put, right? That's important. Well, we have to put plus because this sign goes to negative. So if it's negative, we put plus. Okay? If this sign is positive, then we put here minus. Okay? But because the sign is negative, we put here plus. And the question asks us to find the transfer function of ys over tds. So it means that we don't even have to consider r of s. So we got the basically we got the system. Now we just write them. Okay, tds over g1s multiplied by g1s g2s 1 plus g1s g2s hs equals to ys. If you cancel the two, g1 g1, right? And then our final transfer function is output over input, so ys over tds equals g2 of s over 1 plus g1s g2s hs. So that's it. This is our transfer function for the system shown. So that's one method. Okay, now the other method, which is much simpler, is called Mason's signal flow. I'm sure you've seen in the theory, right, the formula and everything, so I'm just gonna write it down as well here for to get easy access into it. So we have a transfer function, let's call it t, okay, t of s, and this is basically from 1 to k, and then pk, and then delta k over delta. How do you find those? Well, pk is just like what forward path we have, and then the gains of that. That's our pk, and then delta k is shown here. Okay, so that's our delta k, 1 minus sum of gains of all individual isolated loops, and then plus that and minus that. Okay, so let's go ahead and solve it. Before we dive into the equation, we first have to draw the Mason flow diagram. How do you do that? So let's see. Okay, we have an RS, we have this node here, okay, and then we have another node, so, and then we have another node, and then we have ys. We have this h of s, which goes from, let's give the nodes a name: node A, node B, node C, node A, node B, node C. So we have h of s, which goes from node C to node H. So node A, okay, and the sign is negative. We have the input TD is here, and what else do we have? So let's just name them, okay? Name the gains. We have a G1 of S here, G2 of S here. So that's about it. Now for PK, okay, which is the forward path from input to output, and then how many gains are in that forward path. Let's have a look. So our final transfer function that they want us to do is ys over tds, okay? And if we draw the path here, we only have one path. It starts from here, we have the arrow goes there, and then we have the arrow goes there. So how many gain is in that path? There's only one, and that gain is G2 of S. So that's our PK, and then delta K is, again, delta K is equals 1 minus sum of gains of all individual isolated loops. Do we have any isolated loops? No, we don't, because if we say we remove this, okay, is there any loop? No, there isn't, right? Because there's no loops here. So it means that this is going to be 0 because we have no individual loops. So that's it. That's our K. And then what is our delta? Okay, so that's the calculation for our delta. Okay. They say 1 minus sum of gains of all individual loops. So the individual loop that we have is shown in this highlighted area. We only have one individual loop. And what is that individual loop? Well, we have 1 minus sum of gains of all individual loops, which is just minus G1S, G2S, HS, and this minus sign is from here, okay? From here, which is just simply 1 plus G1S. That's our delta. And then our PK forward path, we only have one forward path, okay? This forward path is here. So that means that our PK is forward path, there's just one gain, which is just G2S. And our delta K is 1 minus gains of all individual isolated loops. We have no isolated loops, so this is just 0 or 1. An isolated loop would be if we remove this forward path gain, right? Do we see any loop? No, we don't. So there are no isolated loops. Once we get that, now we just plug in the formula. Again, we're only concerned with TDS and YS. We don't have to consider RS, okay? So that would be PK, which is G2S 1 plus G1S G2S HS. That's it. That's our transfer function. So we see how easy it is with Mason signal flow and how less time it takes compared to this block diagram transformation. I hope that clears out some questions that you might have about this, and if you have any other question or suggestion, please write them down below. Thank you for watching.